Namaste and good afternoon, distinguished guests, delegates, IEDC innovators, and other members of Bhavan's family. Bhavan's Royal Institute of Management, under the aegis of Bharatiya Vidya Bhavan, is renowned for its holistic and academic endeavors for human development. This afternoon, our Innovation and Entrepreneurship Development Center, Bhavan's IEDC, is organizing a platform for different learning experience and are delighted to invite you all for the workshop on blockchain technology organized by Bhavan's IEDC as a part of the Innovators Premium League with Mr. Alok K. Venugopal, blockchain lead, product engineer at LDLT Ledger. He is a BTech holder in electronics and communication from Calicut University, Malappuram. He successfully completed his diploma in electronics engineering with distinction from Sri Rama Government Polytechnic College. He has been also a lecturer in electronics department in Government Women's Polytechnic College, Thrissur. As a vibrant software engineer, he has a great experience in microcontrollers and serial communication. Sir, on behalf of Bhavan's Royal Institute of Management, I welcome you to this session, sir. Now, I request you to take over the session.
Hello.
Yes, sir, you're audible.
Yeah. Okay. Hi. So thank you. So yeah, I can start, right?
Yes, sir.
I'll share my screen. It's showing error. Not sharing my screen. Give me a second. Please let me know when you can see my screen.
Yes, sir, it's visible.
Okay. Yeah, I'll start right now. So hi guys. Last time we had a session on blockchain. So what is a blockchain? How blockchain behave? What are the rules behind blockchain? Everything we discussed on our last session, and I have shown you some demo regarding one. I think one Hyperledger blockchain platform. I have shown one demo also. So today, what we are going to check out is there are several blockchain platforms available. Hyperledger is one of the open source Linux Foundation platform, and there is one called Coda, which is an R3 and supported by Oracle. And XRP, a lot of blockchain platforms out there. So, what today I want to discuss with you and do a hands-on training on Coda platform. So, I'll start with the traditional blockchain concepts, just to refresh your memory, and then we'll move on to Coda. So, before starting, I want to know, you guys have any coding experience? I mean, Java. Do you learn Java part of your syllabus, or are you all fresh to coding? And you can respond. Hello.
Sir, most of us are fresh to coding.
Fresh to coding, right? Okay. Okay. I want to know whether in the end, right, I want to do a hands-off training. So I want to make you code or let me code and let me explain to you and you follow that. So we'll do the second. Anyway, then I will start it. So what are the traditional ledger? So some slides are same from our last sessions. This is to refresh our memory. So what are traditional ledgers? It is a book of record keeping all the financial transactions of the bank or organization. So you're part of a school or college. So your school or college will have a ledger record. It will contain maybe your curriculum, I mean academic details, or maybe the fees details, everything. Everything there will be a ledger available in every organization, and it should follow. It should keep up. Then that's where that organization grows. So the common records are contracts, payments, buy, sell deals, movements of assets or property. So these are all common records that we keep in a ledger. And currently it is centralized. So if it is your organization and you are the head of that organization, then you will be access to that ledger. So whatever happens in that ledger, you can edit it, you can change it, whatever it will be all up to you, decentralized. So consider this concept. So there is bank A and bank B. So they are doing a transaction. So they have a business logic. So they are doing some money, maybe sending some money or acknowledging some money transfer, anything. But there are some business logic behind that. And whatever happens in bank A, they verify that and they have to send that communication or message that communication to bank B, and bank B have to follow. So if any chance that message have any problem or the first bank A run that logic in a wrong way or made some mistake, that mistake will be followed up by bank B. That's what currently happening, and this is before internet. So this is a direct messaging right now happening, and before internet, they call directly. Most probably, they will call the second bank and told them, yeah, this processing we have done, and you can start your side processing. So anything can happen between this communication, and there is a logic running in bank A that may not be the case with bank B. Bank B logic may be different. So this will cause a lot of issues in the future, and they have to sort it out. So that is a problem in the current traditional ledger in a large scale. Yes, not in a small scale. If it is only a small organization, then that is enough. If it is a centralized organization, then that is enough. But in case of large scale, inter banks, inter organization, or even inter region, this is going to be a problem. And there comes this distributed ledger technology, DLT concept. So most of you might have heard this DLT. You have been hearing the related to blockchain or cryptocurrencies. DLT, the word DLT, it means distributed ledger technology. So a distributed ledger is a consensus of replicated, shared, and synchronized digital data. So what's the logic behind is whatever. So it is a communication between, if there are five parties or five organizations, and that five organizations are doing some transaction. If one organization update their ledger, automatically that ledger update will be available in all other four organizations. So that ledger is distributed. That is the word comes from distributed ledger technology. Whatever happens to a single ledger, it will be distributed among all the organization, all the parties, everywhere. So there will be no central administrator. So there will not be a central guide. So whoever wants, so me and one of you guys are doing a transaction, or is part of an organization, or is doing a business. If I update something in my ledger, it will be available to you. And if you update something in your ledger, it will be available to me. If it is a centralized concept and I am the organization, then you, whatever you want to make an, whenever you want to make an update, you have to call me or contact me or message me, and I have to update. And whenever I want to update, I will directly update. So it is a centralized concept. But in distributed concept, you can do whatever you want in your own ledger, and it will be real time available to me. So I can verify that whatever you done is legitimate or it is valid, and I can verify it and I can approve it. And whatever I do, you can approve it or you can reject it, whatever. So That is a concept of distributed ledger technology. All the blockchain platforms, cryptocurrencies, everything running behind this technology. So no centralized data storage. That is one more advantage of that. So everyone will have access to the ledger. Everyone will have a copy of the ledger. So whatever transaction I done, it will be available to everyone in that in part of that network. So if my ledger or if these are all computer systems, they may have destroyed or some natural calamities occurs and the servers may be inaccessible. In that case, there is no problem of data recovery because whatever is available in my ledger, it is available in your ledger also. So in the future, I can make a copy of your ledger. That is fine because everything is safe. So that is no centralized data storage is required. All participants within the network have their own identical copy of the ledger. So that is the concept I just explained right now. So this is just a picture showing that. So this is a ledger. This is person A. If he wants to update his ledger, he can update directly here. So whatever update he make, it will be sent to party C and party B. And party B and C will update the same data in their own ledger and send it to party D. But party C and party B will send to party D, but party D can take any one of them and verify it because both data will be same. If any one of the data sent by one of the parties different, then a total three of the guys are sending the same data. Sorry, two of the guys are sending the same data, and one guy is sending different. Then that guy should not have a problem. So that is another consensus that we cover later. So this is distributed ledger technology. So whatever happens in your node, it will be shared among everybody in that network. So this is another picture showing the same explanation, shared ledger vision. So whatever action happens, it will be updated in a shared ledger and it will be available to everyone. So everyone can update in the directly. So it is accessible to everyone. So this is a concept of DLT or distributed ledger technology. And what is the difference between then? This is the next question. Yeah, you know what is DLT. Then what is this public and private DLT? So there are two concepts of DLTs. There is one called public DLT and another is private DLT. So public DLT and private DLT. Public, it is open to everyone, and everyone will be anonymous. So that is a perfect example for cryptocurrencies, maybe Bitcoin, you can take, or Ethereum. Any cryptocurrency you take, it is open to everyone. So it is public and it is anonymous. Nobody knows who that guy is. So you can access your own ledger and you can update, or you can, if it is a cryptocurrency, you can send or receive money. But nobody knows who you are. Only you have to tell, yeah, that ID is mine and that is me. If you tell that to someone, then only that person will know this is you. Otherwise, nobody knows who that person is. So anonymity, and it is open to you. That is public. In private, it is authorized and identified entities. So private means a DLT network will be created among non-parties. So everyone will know each other. If there are 10 participants in a private DLT network, the 10 participants will know each other, and they can authorize. They have to authorize. If 11th party is going to be part of that private network, then all 10 parties need to authorize that 11th party. Then only that 11th party will become part of that private network. But in public, anyone can join anytime. And if you want, you can create multiple accounts. That also no problem. So that is participation. And in access level, public is permissionless. Like I said, anyone can access. So if you want to create 10 accounts on your name, you can create 10 accounts on your name. But in private, it is permission. If there are 10 parties in that private matter, 10 parties need to approve you, then only you can do anything, or you can you want to create an account, you can create an account only if you get authorization from all 10 parties. Performance. So public means it is open to everyone and it is permissionless. So obviously it will be a slow network because a lot of people will be accessing it a single second, and a lot of operations will be doing right now. So it will be slow. But compared to public, private will be really fast because there will be limited number of users in there, and limited number of operations will be happening in a single time period. So it is comparatively fast. Scalability. So, one second. Yeah, scalability wise, public, it is not scalable because it is a public network and it is available to everyone. So now one person can scale it. It has to be a group call, and it is not that easy to scale in public network. But in private network, it is scalable. So only if there will be, for example, 10 parties will be there in the private network, and if that 10 party can join together, they can scale that network to a high level. And the trust-wise, public network is trustless actually because nobody's know each other. If there is a guy in the public network saying he is the president of America, then we cannot trust him because we don't know if he is truly the president or not. But in private network, if somebody is coming and saying, yeah, I am the CEO of this organization, then we can verify that because it is a private network and everybody in that network know each other. We can verify whether that particular person is the corresponding person. So trust is there. In public, trust is not there. Centralization. Public network, it is actually fully decentralized because it is a public network. So it cannot be owned by a single person. It is fully decentralized and it will be available to everyone. But in private network, tend to learn towards centralization. So even though it is a decentralized network, the decentralization happens between all the parties inside that, all the participants inside that private network. There are 10 parties inside the private network, 10 organizations inside the private network. Then the centralization or the decentralization happens between the 10 participants. So from outside world, it is kind of centralized, but inside the private network, it is decentralized. Then DLT and blockchain. So not all DLT is blockchain or vice versa. It is actually a concept. So if it is a blockchain network, then blockchain have to obey some rules. One of the rules is it should be DLT. But there are technologies coming into picture right now. Without DLT also, blockchain network can be created, but that is actually another discussion. But here we'll discuss between DLT and blockchain. What is their connection? So blockchain was the first fully functional distributed ledger technology. So distributed ledger technology or DLT team was there even before blockchain was introduced. So many people were working on distributed ledger technology, and they were trying to implement that. And one of the best fully functional implementation was blockchain. Blockchain is growing, secure, and shared ledger keeping system in which each user of the data holds a copy of the record which can only be updated if all parties involved in a transaction agree to update. So this is an example. So I will explain this second point. So this is an example. So this is the blocks. So this is first block. It is called Genesis block. That is second block, third block. So each block is data. So for example, this first block is I'm lending you $10. So I'm putting it in the blockchain, and it will create a block. And inside that block, if you decode, it will say, I have lent some particular amount of money to you, and in this block, you have paid me back that money. So that is also updating in blockchain, and I can, if I decode this block, this said you have sent me back that money. And this is the final block. So in the final block, I'm again updating. Yeah, I'm saying I am lending you another, or I had lent you another $20. So how the blockchain blocks are created? So this block will be only created if there is a consensus of that data inside that block happens. So I said I had lent you $20, and you have to approve that, or you have to consent that. Yeah, you have received money from me. So then only this block will be created. So if I'm saying I have given you $20 and you're saying no, you didn't receive it, then there's a mismatch happen, and that this block will not create. So a block will be only created if that transaction is agreed upon. So both whoever is doing the transaction, everyone has to agree. Then only that block will be created. Once a block is created, it can never be deleted. It will be there for always. Any blocks you can create on top of that, any data change or structural change, whatever happens, that block of data will be there always. You cannot delete or edit a block. So that will be only created upon agreement of everyone. And Next is DLT. One second, give me a second. Sorry, I had a call. Okay, so if I'm going too fast, please let me know. I'll slow down. If it is okay on this speed, yeah, I'll continue on this. Please let me know, okay, if I'm going too fast. If any doubts you have, or if any of the slides you have some errors or anything, you can clear at that time itself. You can ask me directly, no problem. Okay, so I can move on, right? Anybody, anyone have any doubts so far? No? I'm assuming there are no doubts. So I'm continuing. So it's a continuation of the previous slide. So I told you, whenever a block create, it cannot be deleted or removed or edited. So that block creation is actually an important task. So how it happens? So A wants to send money to B. So from his laptop, he's updating his ledger, saying he sent some money to B. Then the transaction is represented online as a block. So consider this as a block. This is just an example. Consider this as a block. The block is broadcasted to every party in the network. So in that network, so if it is a Bitcoin network, Bitcoin means millions of users are there. So if for example, there are 1 million users in Bitcoin, so 1 million users are using Bitcoin technology and Bitcoin cryptocurrency, then all the 1 million users system will be updated with this transaction. Say A want to send some money to B. So it will be sent to all 1 million users. So in this case, I'm saying 5 users, all 5 users will be updated with that. Those in the network approve the transaction is valid. So all the parties in that network, or there are so many consensus algorithms, it not need to be everyone need to agree. At least there are some algorithms saying only 50% need to agree, or in some says only 5 of them should agree. So there are a lot of concepts in there. But in this example, I am saying everyone needs to agree. So only if all the parties agree to the transaction, then only it will be created as a block. Because in here it is created as a block, but it's never attached to blockchain. It's just an independent block. Then everyone has to agree to that. Whenever everyone has agreed, it will be attached to the blockchain and it will become the latest block of that blockchain. So the block then can be added to the chain, which provides an indelible and transparent record of transaction. The money moves from A to B, and that money will be moved to B. And so that entire movement, everyone will know that A has sent to B. Everyone should know. So that is the TLT and how blockchain works. And blockchain use cases, there are a lot of blockchain use cases or the concepts behind blockchain. So some of them are cryptocurrency, digital signature, public key infrastructure, PK, you must have heard, hash functions, consensus. So all of this comes together, then only a blockchain network become a blockchain. Or else you can skip one or two, but you have to provide, each one of these party will provide some trust and uh, you know the rules behind a blockchain. So it has to follow. Most of the blockchain platforms should follow all of this. So first thing is cryptography. What is the role of cryptography in blockchain? So what is cryptography? Cryptography converts data into a format that is unreadable for an unauthorized user. So here I'm sending some data to you and it is cryptographically encoded, which means you you can read it, but whoever you, if you are sending that message to some other people, they will not be able to read it. What they see is some gibberish words, A B C D F G, some words are there, but it will only make sense to you because it is cryptographically encoded, and I only shared that key with you. So there is a sharing of key concept that also I'll explain here. So encryption is the process of turning plain text into cipher text using an encryption key. So I'll be using one encryption key. It will not be a physical key. The key means it will be a hash code, something like this. Maybe you can consider this as a key. So 12345, it is a key. Maybe my name, that is a key. So kind of like a password. So there will be a key. It should be a long string, maybe 16 to 32 bit long string, but there should be a key. And using that key, I will encrypt my plain text data. So my plain text data will be encrypted. So some algorithms will run behind and it will join together my key and the plain text data. And it will convert it into cipher data. So that cipher data from outside world, everyone will see it as some gibberish data. But with the correct decryption key, you can decode that plain text from that cipher text. So decryption is the process of turning cipher text back to plain text using a decryption key. So this is plain text. This is dear Bob. So I have an encryption key. So for example, I can say 1234 is the encryption key. So if I encode it, it will look like this. Dear Bob will turn to 38562173, some numbers, long string numbers. Nobody know what it is. But secretly, I have shared you my decryption key. That is 3456, for example. So I have shared you 3456. So you know the decryption key is 3456. You can always use that 3456 and decode this data, and you will get back dear Bob. So that is the concept of cryptography. And there is a concept of hash function. What is hash function? So do you know what is hash is? If you are downloading softwares or programs or some anything, maybe documents, in some sites you will see it is hash. You will find some hash code behind that software. Say for example, if you are downloading Linux OS from Ubuntu, maybe you can take Ubuntu, which is open source and available. If you want to download Ubuntu, you go to Ubuntu site, you can download the ISO file from there. But below that ISO file, you will find a hash MD. So there is a hash string, so something like this. A long string will be available in there. So what is the concept of this hashing? So hashing is a concept of converting a large number of data into a particular number of hash function, which can be verified later stage. So there is no tampering happen to that original data. For example, I have a data. So this is a data from person 1 to person 2, amount 5,000. So this is a data. I'm sending it to another guy. So I'm person 1 and I'm sending to person 2 and the amount is 5,000. So if there is a hacking happen, just an example, hacking happen, there is a man in the middle and he received this data, that is person 3. He changed this amount to maybe 10,000 and sent it to person 2. So from my concept, I have sent 5,000. In that message, I have clearly said 5,000. But from person 2's perspective, he received 10,000. So there is a problem happening there, but I am not aware of that person 2 received 10,000 and person 2 is not aware of I have sent only 5,000. So in order to in such cases, we use hash function. So what will happen is this entire input I will convert to hash. So this is the hash, and I will send this hash separately to that user. So if anyone, any person do any change, maybe a dot or a space, any change, a small change happens to this message I have sent, that entire hash function will change. Everything will change. So I have sent this input and hash to the person 2. So person 2 always can generate the hash of whatever he received and compare it with the hash I have sent. If it is same, then he can confirm, yeah, that is the same data I have sent. If there is a difference, then he can say that input there is someone changed some data in there, so that is not the correct version. So that is the same concept we are using in blockchain. A hash function is a mathematical operation that transforms input data into an output digest. The input data can be of any size or length. So input may be 100 MB size, but the hash will be always constant. The output hash usually is a fixed length. There are many type of hash functions, MD5, SHA-1, SHA-256. A lot of algorithms are available, and we will be using any one of them. So SHA-255 is one of the secure. So we'll be mostly using SHA-255 in blockchain, but there are blockchain platforms using MD5 and SHA. So I have told you an example in this chart saying when you download ISO file from Ubuntu, you will see the hash function. So what you can do is you can always download that ISO from Ubuntu site. Then you can create a hash of that ISO file you downloaded, and you can compare that hash with the hash in the website. It is same, then you will see the correct ISO. If it is not same, then whatever click on the button to download, but what you downloaded is something else. So that is for security, it is put there. So that is hash function. Then there is a concept called digital signature. So I'm explaining all this because these are all going to be part of the Coda platform or Coda blockchain network, which we are going to do a hands-on training. So it will not be directly there, but these are all the concepts behind it. So I just want to know all this concept. That's why I'm taking all this. So I'll come back. Any questions so far? Okay, I'm assuming there are no doubts. If you have doubts, please directly unmute and ask me. No problem. Okay, moving on. So then comes the concept digital signature. So what is a digital signature? So you all go to Akshaya, right, for some documents from village office or something. So you'll find from Akshaya, you'll receive a sheet of paper, and there will be a green tick in there. It said it is digitally signed. So what is that digital signature, or what is the concept? So a digital signature is a technique that guarantees that the contents of a message have not been altered in transit. It is kind of like the same concept of hash function, but it will ensure that in transit that the content of the data is not changed or not altered. So what happens in there is a public private key pairs can also be used to create digital signature. You sign the hash of a message. Okay, that is one way you sign the hash of a message using your private key. Producing a digital signature, you send that digital signature alongside the message. So instead of sending the hash directly, so this hash also can be hacked and maybe changed, right? So in order to compensate that, we sign the hash with your private key. So in the starting, you will have one public key and one private key. That is how a digital signature starts. You have to create a public and a private key, and whenever you send a message to somebody, you will sign that message with your private key and send it directly online. So it will be available to everyone. Everyone can see that message. But the problem is, whoever has your public key, then only that guy only actually can see it. So you send the digital signature alongside the message. Someone else can take the signature along with the message and your public key and validate the authenticity and the integrity of the message. So with your public key, which will be available to everyone or whoever you send to, and with that public key, that guy can validate and authenticate it, and they can say it is a valid transaction. So that is the concept of digital signature. So there will be two keys. One key is for signing, and the second key for decrypting. And this will happen vice versa also. If you are sending some sensitive data, so some other guy wants to send you some sensitive data, he will encrypt that data with your public key and send it to you. So that is a sensitive data. So for example, that is a password to your bank account. So that is signed by your public key. So public key is available to everyone. So any hacker will be access to the public key. But the person will sign that with public key and send to you. So you received that same data and the hacker received that same data. But the hacker will have only the public key. So with the public key it is encrypted, but for decrypting, public key is not used. For decrypting, private key is required. So only you have the private key. So anyone can encrypt and send data to you or to the website only whoever has a private key, which is you, can only decrypt that data. Only you can see. That is one of the concept of digital signature. Okay, then consensus. What is consensus? So I have told this name or this word so many times from starting of this lecture. So let's check it out. A consensus is a way of coming to an agreement. So consensus means it's a word used to or say yeah everyone comes to an agreement. A centralized system without a common consensus will fall into pieces in a second. So all blockchain or most of the blockchain networks are actually decentralized networks. So decentralized network should have a concept of consensus. If there is no concept of consensus, it will fall into pieces. It will not work. It will. I'm not talking about blockchain itself. All decentralized systems should have a consensus mechanism. So consensus is an agreement. So there are 10 organizations in a network. If there is a consensus in there saying all 10 needs to agree. So that is a consensus. All 10 needs to agree to imprint their data into blockchain. Or there is another consensus here saying only guy 1 and guy 5 should agree. So that is a consensus. So if either guy 1 or 5 agree, then only the transaction will move. Or you can say guy 1 and 2 has to agree, or else everyone should agree. So any concept, any logic you can implement, but consensus is a concept of coming to an agreement. It doesn't even matter whether participants of the system trust each other, particularly or do not trust each other. So consensus shouldn't care about anyone trust each other or not. So if you trust each other, you'll say only single signature is required. If you don't trust, you'll say everyone should say. And that is a concept of public. So in public, there are some consensus mechanisms in public decentralized blockchain networks, and it will ensure that even though if nobody know each other and nobody trust each other, the transaction will or go through. So that's how consensus. All the same, they need to agree on certain principle of functions that would be common for all of them. So that, which I explained before, everyone should agree to a concept or a logic. So that logic will be implemented in the such a way that even though they don't trust each other, they don't know each other, an agreement should come up in the and that agreement come up in the ensures with the help of this consensus. There is no one universal method of reaching consensus. So in anything you can implement to provide trust and moving forward. There is no good or bad consensus algorithm. It's only about the requirements of the account system. So it's all depend on the system. If it is a private network, the consensus will be different. If it is a public network, the consensus will be different. In public network itself, there are so many applications of blockchain. Everywhere, the consensus will be different. So it's all up to the system administrator. And these are some examples of consensus. Proof of work. If you heard, if you know, proof of work, this is the consensus algorithm which is used in Bitcoin. There is proof of stake, which is a consensus algorithm used in Ethereum. There is Byzantine fault tolerance, which is a consensus algorithm used in Hyperledger. Then proof of elapsed proof of authority, a lot of, and a lot more. A lot of consensus algorithms are available. So here we conclude a recap of our last session and some extra concepts we learned in here and common to blockchain or DLT. Any doubts? We are moving to Poda session. Any doubts you can ask. Okay. If I know, I will answer you right away. Or else I will check out and come back. Okay. Assuming having doubt or else do you understand? You're getting that ideas, right? Is it okay? Do you want me to continue in English or in Malayalam? You're not getting the concept clearly. Maybe I can continue with Malayalam. Whatever.
You may continue in English, sir.
Okay, then I'll continue. So I'm going to Coda. So what is Coda? So I'll just show you the website. So this is a Coda website. So yeah, I'll share all the links and everything in there. So I'll give you a short idea on Coda. So Coda is kind of a blockchain network. So I will not say it's a complete blockchain network. In the site you will see Coda is blockchain, blockchain, blockchain. But actually it is not directly a blockchain network. It is a distributed ledger technology network. So it follows all the rules behind the distributed ledger technology. So it has a vault, and that vault is encrypted. A vault has all the digital signature, digital signing, all the concepts are there, but it is not completely a blockchain. So there is no blocks in there, but it follows some other concepts. The main advantage of Coda is it is really built such a way that it can be used in finance sectors clearly. So from my understanding is correct, ICICI Bank currently trying to implement a blockchain network in the India sector, I guess, and they are implementing with Coda. And a lot of financial institutions are trying to create their own blockchain network, and they are choosing Coda for that. It is because like I said, it is not completely a blockchain, but all the logics and transactions and all the algorithms behind it is actually more clear and more supported for financial sectors. Not, I'm not saying it is bad for any other sectors, but it's more suited for financial sectors. So it is one of the emerging blockchain networks. So that's where we'll be focusing on this one. So what is Coda? So Coda is an open source distributed ledger technology platform. So it's not completely a blockchain, but it is a distributed ledger technology platform. The Coda platform is mainly built for financial transactions. The traditional blockchain platforms lacks privacy and finality. Coda tries to solve these problems. Transactions in Coda are fully encrypted and it is only shared with necessary parties that are involved in the transaction. So this word you have to keep in mind. Parties means one particular node or one organization in that network. So you will see parties a lot. In Coda, they refer all the entities in a network as parties. They'll say party A want to send money to party B, or party B want to send some transaction to party C, like this they say. So parties are entities in that network. So in introduction, Coda focused on resolving following issues with the traditional blockchain system. So this is what they are trying to solve with their system: privacy, transaction finality, legality, identity at parties, ability to scale, productivity, and enterprise integration. So they provide a lot of integration options and in-depth blockchain communication options. So, they are really good. So there are some concepts in Coda you should know about. So first thing is ledger. So it is common to all blockchain platforms. In Coda, there is no single centralized ledger. So there is no single ledger. So it is a distributed ledger. So everyone will be access to everything. So each node on the network maintains a vault. So here the ledger is named as vault. So a ledger, we in the outside world we say ledger. In inside Coda we call it as vault. So everyone will have their own vault. So there is Alice, Bob, Carl, Denny, Ed. Everyone will have their own vault. Each node only sees a subset of facts on the ledger. So this is a vault of Alice, and Alice have two transactions, and that transactions are with the Bob. Then in Alice ledger, it will be updated, the transaction 1 and transaction 7. But only Bob can see it, no one else can see it. And in Bob's ledger, it will be shared. So from Bob's vault, you will see 1 and 2 in there, also 6 and 5. 6 and 5 is a transaction done with the card. So the 6 and 5 will not be accessible to Alice. So whoever is part of the transaction, they can only see. From their perspective, if you go to card's perspective, a lot of entries are there in his world, and it is done to three parties. Actually, he have done transaction with the three parties, and that transactions are updating in the world. So this is explained in here. Alice Walt will have 197. Bob has 1765. Carl has 946523. Likewise, it will not go. So that is the concept. Here you look into three. Three is an operation done with the card, add, and debit. So all three will have access to three data. So that is this is the concept of ledger or vault, which I guess you already know. There is a concept of CODA network. So what is a CODA network? So in CODA, each party or each node or each entity is represented as node. So we'll call Alice. Alice has a node in there. We'll call test node, and Bob has a node. So that we call it as a node. So everything, every entity in a CODA network, we call it as a node. So aside from Alice, Bob, all those parties, there are some extra nodes in there. Some of them are not true. So there will be a not-tree node in there. There will be a network map. There will be identity manager. There will be some maintenance. So these are actually maintained. The entire CODA network, if they want to run, they needs to be maintained. They need to be overall needs to verify the users, verify the transactions. All this can be done by some extra parties. They are called nodes, and the examples are not-tree and network node. And then only all other nodes will come. We will explain detail what each of these extra nodes do. And one another concept in CODA is state. So, what is a state in CODA? So, I have shown you here that 197 is updated. That is a data. I told you that is a data. So, this data is called state. So, 1 is a state, 7 is a state, 6 is a state, 5 is a state. So, in Alice Ward, 1 and 7, both the states are available. You can say in Bob Ward, there is 1765. All four states are available. So state is the status or the representation of the data in blockchain or in CODA world. So state is an immutable object representing a fact known by one or more CODA nodes at a specific point in time. So at a specific time, what is the data which is acknowledged by all the parties and they put it in blockchain, and that is called state. So this is an example of state. So it is an IOU contract, and the participants are Alice and Bob, and the properties are Alice from Alice to Bob and Dolly. This particular date, and paid $5 penalty of 20%. You don't need to worry about the content, but this is how state look like. It will say what type of contract it is. It will say who are all the participants of that state and the property of state, which states all the from to amount or any other properties of the everything and your date. So this is how a state look like, and it will be saved in vault or blockchain. So state represents shared fund. State can represent anything. Once a state is created as a particular type, it cannot be changed to another type. So if a state is created with IOA contract, and it cannot be changed from that. So state will continue following a. So whenever you create a state, you have to know what you are going to do, because in the future also you have to follow that. Then state and vault. What is the relation between state and vault? So states are stored in vault. It stores and tracks all consumed and unconsumed state. So there are two types of state. One is called consumed or historic. Another is unconsumed or current. So for example, I'm lending you $10. So I'm updating my ledger with the state. I have sent you $10, and that will be updated, and that will be known as unconsumed state or current state. And after 2 days, you have paid me back that $10. So you will be updating in the ledger. I have paid $10 back to him. So when you update that, that will become the current state, and whatever I created become historic, because that is history. I have sent you some money, and that was current at that time, but you send me back. So you have updated. So whatever message I created, which is I have sent you money, that becomes stored, that become consumed stored. So that is consumed and unconsumed. The sequence head reflects the current state of the shared file. So the current state, the latest one, will define the state of the asset. So there is a bank account. So you are keeping a bank account balance. You have $10,000 in the. You are taking money from the each week, maybe $100 per week. So what is the latest state? You can check the current state, and you can see you don't need to look in the historic state. Historic state is to verify that current state is true or false. From historic state, current state, you can verify the latest state, amount balance in your bank. And there is a concept called contract. So what is a contract? Contract is used to verify state changes. So there is a state change. I'm sending you money, and you're saying you send me back. But this send me back, that is verified by this contract. So contract is the guy, or contract, there's a concept of contract. But in the contract, there will be some logic will be written, and that logic will verify. Yeah, you have sent me money, but is that a valid money transfer, or any other parties need to be updated, or all those things. It will do all those things, and it will then only it will do a verify. Whenever it verify a transaction, then only it becomes state. If contract logic is not satisfied, the state will not be put it in vault. So contract mandates that each state must refer a contract, and multiple contracts can be referred in a transaction. So in a single transaction, we can create multiple contract logic. So if everything maybe it will go through all the contracts and it will verify everything, then only it will put it in the vault. Contracts control the evolution of state. So the entire evolution of state depends upon contract. So state is actually a representation in the world or in the DB, and the contract is the one who governs it. All the rules, everything will be specified in contract. Then there's another concept that is called transaction. So what a transaction contains. So this is how a transaction looks like, a single transaction. So an example is I have lent you some money. So that transaction will have an input state. Either it will have an input state or there is no state. That is condition. So if first time I am seeing you and I am lending you $10, then there will not be an input state. So there is no starting state. I am starting it. So that is the input state. Or in case you are sending me back some money, then the input state is I lend you money. So I lend you money first, then you send me back. So whatever I send you money, that is input state, and output state is you lend me money. So that is output state. So those are those state commands. Commands are the logic we implement in contract, and there are attachments. Maybe to satisfy that money exchange, maybe you can attach some video. There's time window and there is notary. So there is a concept called notary in order. So now what notary do is main task of notary is double spending. Verify whether there is a double spending or not. So for example, I'm in my bank account there are $10 and I'm giving you $10. Tomorrow I am again giving $10 to some other guy. Next day I'm again giving $10 to one person three. But initially I only have $10 in my account. So actually what I'm doing in there is with that $10 I am sending money to three people. So such cases this notary will red flag that. So whenever I send you money, that $10 my bank account will be zero. Then again if I try to send again, this notary will red flag and notary will not let the transaction move forward. It will block it. So double spending. You have an asset and you can only transfer that asset to some other guy. You cannot make a copy of that asset and send to multiple guys. Such things will be verified by notary. And there is a concept of flow. So Coda flow describes a step-by-step process by which nodes communicate with each other to reach consensus over a shared file. So we have a contract. In contract, we will implement the logic. We have a state which will represent that logic, and we have a flow which will send that represented state to all the parties. So this is a distributed ledger. So this distributed ledger, whatever is implemented in my node, I have to distribute it to all the parties, or all the nodes, or all the organization. So that is done by flow. So inside flow, we will write the logic that whatever is implemented in my ledger for this particular state, it needs to be shared with everybody else. So Quad flows automate the process of agreeing ledger updates. So I told you there's a concept of consensus in blockchain. So everyone needs to agree, or there will be some consensus algorithm. So one guy needs to agree, two guys needs to agree. So those algorithms will be written in flow. So in flow will verify and make sure that transaction is signed out. Quota flows control uh, when to communicate, want to communicate, and with whom to communicate. All these communication related items will be controlled by flow. So this is an example of flow. So Alice Bob. So Alice created a transaction, verified it, signed it, and sent to Bob. What Bob do is Bob verifies it, verifies the signature, verifies the transaction, and he also sends it. Then it will be sent to Alice. So what Alice will do is he will finalize that transaction and send it to Notary. So Notary will check whether it is a double spending or not. If it is not, it will commit the transaction. He also sign and send it back to Alice. Then only Alice will save it in its vault and send that copy to Bob. Bob will save it in vault. So this is how a flow will occur. So these much transactions will happen for a single $10 transfer. So yeah, these are all the slides I want to share with you today. Any doubts? Please let me know if you have any doubts, so we can start the ready. Okay, then I'll start the train. I'm guessing you all installed IntelliJ. That's a software I asked to install last time. I have sent that link. Everyone got that link to install IntelliJ in your laptop or system. So IntelliJ
The
Community
link for
Edition.
feedback has been posted in the chat box, requesting all the participants to fill in the form.
It's need to be filled right now or in the end of the session.
End of the session, sir.
Um, okay, please respond whether you have installed IntelliJ or not. You have to have IntelliJ, and only we can continue. If not, maybe I'll share you the link right now. You have to download and install it. So you have to install the community edition. You can download from here. I'll share that link in the chat. But if it is not installed, it will take some time. That's why I send that link beforehand. Can I assume everyone installed it? Hello, anyone? Maybe
Yes, sir. So
explain
I
it
have
shortly.
shared to the students. I have shared to the students.
Shared it to everyone, right?
Yes, sir. Yes, sir.
Okay. And you actually there are several items you need in your laptop. So you are required to install IntelliJ in the and you are required to install Java version 8 point maybe 221, 8.221. So I have shared that link with Nivin also. I'm assuming that also shared with everyone. So you have already downloaded and installed it. Uh, if that is the case, maybe I can start. Okay, anyway, I'll start it then. So have you used Git before? Uh, Most probably you will not. I'll just ask you. So if you don't know, I'll explain. So Git is actually a developer, um, code sharing or code saving site. So here you can you'll find. So there is a link I just shared right now, a Git link. So Git Coda sample Java. So if you go to that link, you will see this page. So this is actually a Coda open source, some examples and codes available here. So right now we don't have any experience in Java, so I don't want to make all of you code anything. So I will just go through the code and maybe we can discuss. And if you are interested, you can move forward from that. So that is my plan today. So what you can do right now is you can that link I shared right now. You can go to that link and you will be here in this page. What you can do is here in this green button, if you click, there is an option called download zip. So you can download this entire code in zip format from here. Can you do that right now, everyone? So go to that GitHub link I just shared. In the there is a green button on the right side. Code. Click on that and click on download zip. If you have if the downloading is completed, it doesn't have it is not that much big. Maybe around 50 MB or 100 MB max. I don't think it is that big, but if you are done, please let me. You are doing it right, everyone. Try it if possible. Mm, you are done. If you're done, it will be. If you unzip that file, you'll find sample Java folder. Inside that, you'll find a lot of folders there. You have to go inside basic. In there is a Coda example folder. You have to go on there. Actually, you can right click on this Coda example and you can open as integration. So if you have already installed intelligent automation, you can do this. I'm not getting any response. So if you're stuck or something, please let me know. Or else I can continue. Yeah, I will continue that. So I'll explain a bit. So it will be easy for you to explore in the future. So this is Coda sample folder, which you just drop on. You'll find a lot of folders in there. You don't need to worry about any of them. So what you need to know is you can open this gradle properties folder. Okay, we can open build.gradle file. So in that file, I'll explain to you what is build.gradle. So it is essentially a Gradle file. So what Gradle is used for? I know you are all rushed to Java. So there are a lot of concepts in Java, and this is actually Quad is actually a Java application. So uh, I will explain to you. So whenever you write an application in Java, there are so many dependencies are there. So many dependent softwares are required in there. Say for example, you want to calculate a time. A Java application, you are writing a Java application and you want to calculate a time. You can either code. So you can line by line, you have to code to fetch the system you are running. If it is Linux or Windows, you can fetch that. And then from that, you have to fetch the system time service. And from that, you have to fetch the time. So that's actually several lines of code you have to spend some time. Or else, what you can do is there are so many dependent libraries currently available for or common methods like maybe time. So what you can do is you can just download that package. Time fetching. I'm just saying an example. Time fetching job. So that is a jar file which is commonly available, which what it will do is it will fetch the time directly and send you to you. So what you can do is you can add that jar file to your code. Then with a single line you will get that. So as lot of such dependent softwares are currently available, jars are available. So most of the coding people, what they will do is highly available such things will be fetched to the repositories, and then they will run, and the coding will be much more easy. So that is the basic concept. So this gradle, what it will do is it will download whatever it is. If there are some dependent softwares or dependent libraries or anything required, you can code it in here and you can download and put it in your workspace. That is one thing. And another thing in Coda, here it is explained about all the nodes in the network. So the Coda example you just downloaded, which is automatically comes with the two parties. Party A, that's one participant or one organization in network, and this is actually the naming convention in Coda. O is equal to organization. So O is equal to party A, L location. Location is equal to London. C country. Country is equal to GB. Likewise, or party B is in New York actually. So O is equal to party B, or I can give Alok here. O is equal to Alok. I can give. So L is equal to New York and C is equal to US. So these are the two parties here, and these are the two parties going to do transaction. And there is one extra guide, third guide, or not read, which is common. The location is not relevant in here, but you have to give location. So organization is not read, the location is London, and it's easily. So there are several extra items required in there, like peer-to-peer code. So that port number is given. It is automatically given in there, so you don't need to edit anything. If you want to change, if you know what you are doing, you can change it, no problem. Or else you can follow it. So there are RPC communication address, which is localhost 10,003. So I'm planning to what I'm planning to do is I'm planning to run everything in my laptop here right now. So all three nodes will run in my laptop. So that is my plan. So this is what going to be the RPC. RPC means communication. If I want to communicate to Montreal, I have to communicate to Dr. Lowe's, this particular, and this is admin address. That same goes for everything. RPC username and password. This all we can, if you want to change it, you can change it. But right now, you don't need. So that is one file you have to look into. Another file is in this workflow folder. If you open workflow folder, there will be an SRC folder. Inside that, there will be several folders, but you have to focus on this main folder. In there, you will find Java. In there, you will find example flow. I will open that file. So this is a flow example. So in this slide, I have shown you three main entities in code. One is state, another is contract, and third one is flow. So I'll open all these three files. So if you want to code basic, not advanced, so actually, if you want to learn code, it will at least take 2 to 3 months completely. You have to spend at least 2 to 3 months completely on code, and only you will learn maybe 30–40% at least. It is a vast, uh, a lot of applications are there, and a lot of things to be learned. So this is just 1 hour session, so I cannot do anything in here. What I can show you is I can introduce you, I can show you how it is coded, I can explain you how it is coded, and I can give you some links. And from there, I can help you run it in your own laptop. From there, you can cut it. So that's my plan. So this is flow, and if I go to there is a contract folder here. I go to contract. Same. There is a big folder. There's a main folder. In the if you go inside contracts, you will see one contract file. That is IOA contract. So that is contract file. In the itself, there is a schema folder. That is database file. You don't need to touch that right now. There is a state folder. If you open that, it will explain the state. So these are the three files. If you are starting, if you are a beginner, and if you are interested in blockchain and interested in Java coding, then these are the three files you should focus and start learning and start editing, and you can run and you can play with it, basically. So these are the three files you should focus on. So the files are in two folders. One is in contract, other is in workflow. In contract, you will find there is a contract folder and a state folder. Inside contract folder, you will find the contract. Inside state folder, you will find the states. Is it? Hello? You can follow it, right? Anybody doing it actually? You don't need to know coding right now, because I will do it simply, and you can run a blockchain network in your laptop. So that is a plan. So, and if you are interested, you can follow. Um, then another question. So do you want me to explain the code right now and run it, or maybe I will run it first and show you how it's working, and maybe after that maybe I can show you the code. Which one do you prefer?
So you may
So
continue, sir.
I'll do one thing. I'll run it first, and after that we'll see. I will go through the code later stage. Okay. So like I said, these are three files. So what I'm going to do is I'm going to build my project. So I have a Coda project here, Coda. So I'm going to build it, and let's see how it can be built. So Java applications usually build different ways. So this is actually a code application. So you should follow this. What you can do is you can open a terminal. So terminal button is available here on bottom. If you click on that, the terminal will open in the current folder location. This is my location. So here, what you can do is, what you have to run is dot slash gradle w deploy nodes. So this command you have to run. I will can paste it in the chat. You can run this command in the terminal. Simply this one. It will take some time. It will take at least 1 to 2 minutes, uh, depending on your system. Sometimes it will take less. I have a lot of applications currently running in my laptop, so it will take most of 1 to 2. So here you will see it is a task deploy nodes, which is written in this build.creative file. What it is doing is it is using this three file. Actually, there's one more file, a schema, but I'm ignoring it right now. With this three file, it is going to uh, create all three nodes, and after it, party A, party B, all three nodes it is trying to create of the required file structure for the nodes. So I'm waiting to compile. And if anyone doing it, please let me know. make this screen sharing and calling is taking some CPU. So just okay. Okay, it is done. So it took an almost 5 minutes, 15 seconds to build my application. So if you see this build successful, then that is it. If it is failed, it will say in red color failed. Build is failed, and you will see a lot of error logs. So if something like that happened in your laptop, please let me know. It is all build successful. Then I will continue. So what you have to do is, so this is the folder. You have to manually go to that folder. So this is Godard folder. There you will find a build folder. So this is a folder that right now just created by running that gradle deploy nodes command. So I open that folder. In there you will find nodes. I'll open that, and you will find party A, party B, not really, three parties. So ideally, what should happen is, for example, I am party A. I'm from India, and party B is actually from maybe New Zealand. So what I have to do is I have to run this party A, this folder, copy this folder to my server or Indian server, and this party B I have to copy and send it to that New Zealand guy, so he can run it from his New Zealand server. So that is the concept here. But for testing purpose, I will running all three nodes in my computer itself. So for that, what you can do is here you can type in cmd. So a command prompt will open in this location. In there is a file run node.bat. So that's what I'm planning to run. So I'll first check Java version. It should be 8.021, which is the link for downloading this particular Java version. I have sent the link to Megan, so I'm guessing everyone should have received that. You can download and if you download and install it, you will find this Java version 2 8.221. Or else most probably Open SVK, OpenJDK, something like that, and some other latest version. Latest version will not support. It should be 8, 8.0 version, or else it will throw. So I'm going to run this run nodes. So what I'm going to do is I'm going to run nodes. Dot bat. Sounds like a or maybe it is taking some time. Let me wait for a second. Because actually 3 nodes are going to spin up on my single laptop. So actually it should be one node in one laptop. Actually concept. So that is also not going to run. Maybe it is taking some time. I will just wait for some second. Yep. So if you run that script, you'll see 3 windows opened up, and you'll see like this Coda and some gibberish words, and it will run. So we'll wait for it to run completely. So and it should be party A, party B, and then apply. So this is party B. This is party A, and this is no. We'll wait for it to run completely. So after running it, it will show it will show the ports or product details everything. So still running right now. It will take some time. That's it. So here it is waiting for input from us, right? And everything is running fine. Anyone reached with this stage? So we done nothing, just found that repo, we build it, and we run it directly. We return nothing, we return nothing. So I said, I told you, so there are 3 main concepts in Coda. One is state, other is contract, next is flow. So flow determines the communication. So whether A want to communicate to B, B want to communicate to A, who all needs to be signed, whether an order needs to be signed, all those things, all those logic is written in here. So flow is the thing that is available for us to communicate. The state and contract will happen in the background. So if you do a flow list, you'll find all the flows currently created in here. So these are all the flows currently available in here. So for testing purpose, so this Coda sample you just cloned, right? This application we just built. I will explain to you that. So that is actually an IOE application. So that is an application already code is there. So that application is used to send money to other party. So here we can send money from A to B and B to A. That is the business logic of this application. This example, code app example, we just downloaded right. So what I'll do is One second, I'll stop my presentation. Hi, sorry, I had some issues with this. Yeah, we'll continue. Okay, so what we are discussing is we have party A, party B, and market. So this application we just built, it is used to send money from two parties, and the market will verify. So let's confirm. First, I'll run this command. So this is run vault query. This is to check whether is there any transactions in vault or not. So I will first run it in party A screen. So I run it, I will get back a result. Nothing in there. Everything is blank. State is blank. State metadata is blank. Other result is blank. I will say the same one in here. And here also it is blank. So what I'll do is I'll send some money from here to here. So this is a command to send money. So the thing is, I should say start. Then I run the flow list. So I can see all the flow. So initiated flow. So I have to call the initiated flow. The initiated flow requires IOU value and other party. So how much amount I want to send, and the next party, whoever I am sending, that party details, the party name. So remember in IntelliJ, I showed you in Gradle, build.gradle file, all the party names. So this is not real. This is party A name, and this is party B name. So I will copy this name and I'm going to copy this command, and I'm going to run from party A. So from party A, I'm saying start initiator. The IOU value is 85. So I am sending 85 rupees or dollar, whatever, to other party. The next party is party B. Location is New York and the country is US. So I'm going to run that. So right now the signature verification done, the verifying contract done, signing done, and right now it is collecting signature from party B. And after that it will be sent to notary. After that it will come back here. So I have shown you in the slide, right? So how the flow works, everything done, and I get a signed transaction ID. So let me run the previous command, run vault query. So this command, run vault query, which will get me with all the data in the vault. If I run that right now, I have got details. As you can see, the value is 85. Lender is party A. Party A lends some money to borrower, party B. Then there are some IDs, some hash keys, signature keys, transaction hash, a lot of blockchain stuff you can see in there. But the main data is this, the value, lender, and borrower. It is now available in party A. So the data is sent from party A to party B. So automatically this data should be here. So if I run a vault query here, you can see the same data, exact same data right now here. Now you can run this again if you want with some other value to party B, or maybe you can give party A details here, and you can run that command from party B. You can send data each other, and you can see that in blockchain. So this whenever you do this vault query, So it is showing data from Vault. So Vault is a ledger in Coda, and in Coda you can see all this data, and all this verification and everything is done by Code, not running in here. So right now it closes this module. So this is party A and this is party B, and they are doing transaction each other. Understand? If you want, I can run one more query. Maybe instead of 85, I'm giving 1,000 rupees. Party A is giving 1,000 to party B. I will run this command in party A. It will do all this verification, and if it is done, I can do a vault query. In party B, and I can see this data. And likewise, you can send the reverse also. So you can do this fault query and not read. And you can see currently that what of that application or what of that transaction happened, not tree is not signed yet. So sometimes some applications, so in the business logic or in the quarter contract logic, not tree is not prepared for that particular transaction. So not tree is not signed yet. So everything you can see from here. To exit or to stop, you have to type in exit. So it will say goodbye and it will shut down one by one. So type in exit. So everything is down. You can close back. I will conclude these commands in the start. And to run all nodes, I ran the command on nodes dot back or Java minus on nodes dot Java. Either one is fine. In one of this we can run and it will run. So these are the commands. Anyone tried it? This is just straightforward. Any doubts so far? Or are you getting? Actually, you have to try it. Then only you will know. Seeing is different. You have to run it in your laptop. Okay, so I'll continue. So I'll explain you a bit of the code. So, not deep. I know most of you are bored, and I don't want to stretch it, but I'll just give you an overall picture of the code. So maybe today or tomorrow, any day, if you wish, uh, you can go through this code and you can verify everything. So I'll start with the state. So I have opened three files. So I told you the three files are the most important files in here. So this is the state file, state class. So what defined in state class is uh, in database. So there is a database behind Coda. Right now it is using H2 database. So in H2 database, what are all the values? I have shown you the state in the slide, right? So in the state, it is an example state. It is the from to, then how much money, and there are a lot of data in there. So same thing. So in this Coda application, what I'm running right now, I have to explain here what are the states properties of that state. So here I have given four properties. So this is a package example dot state I have added here, and I have imported some Java Java and Coda utilities, and here I'm starting the class. So here I'm saying an integer. You don't need to know Java, but basic something, right? C, something you have seen, I'm assuming. So private final, you can ignore all this private final, everything if you're just not getting it. You can follow as it is, no problem. So it is a value. So first property is a value, and its data type is integer. Second is a lender. So who is going to lend? So that is a party. Third is a borrower. So who I'm lending to? That is also a party. And a linear array, which is an internal thing it uses to identify each transaction. So these are the four values I'm creating in this state IOU class, and I'm assigning it. So I'm creating a public class with the IOU state. So these are all Java related, and these are all getters and setters. You can ignore all this. So basically, if you create this part, you can select this, you can right click, you can go to generate, and you can actually create all the getters and setters, everything. So these are all deep, like you can ignore all this right now. So while testing it, you don't need to know. Then you have to learn Java, and step by step you can add values and change values and everything. So currently I'm just explaining in the state. It is all these properties of the state. I'm explaining the everything else you can ignore. These are all setters and vectors. Then in contract, I will explain the rule. So I'm saying first rule is it is saying as state. I have imported everything and created the class IOA contract, implements contract. So these are all common actually. These are common. If you want to write new product logic, you can just copy paste all this till here. From here only the logic start. So the logic part only you have to change. Everything else you can directly copy paste. So inside verify, I'm saying now input should be consumed when issuing an IOU. So there shouldn't be any input consumed when issuing, when creating an IOU. So I'm sending $83 to it. So there should be no IOU straight. So that is the logic here. Transaction dot get input is something that is tricky. And another rule is only one output state should be created, and the lender and the borrower cannot be same entity. So these are all rules that needs to be followed when a transaction comes. Only all of these rules is followed by the transaction when the transaction is. So all those rules are explained in here. So like I said, only this part. This is the main part, and this is the part. The here, if you want to change the logic, you should change it. Everything else you can keep it as is. Then comes the third part, that is flow part. In flow part, it is where that flow happens. So the data center. So there are a lot of logic happens in here also, but for you to know, if you want to test it, you want to change it, you don't need to touch this part actually. This flow you can keep as it is. It will run as it is. You can change the values, change the property values in state, and you can change the logic in here. And the flow you can keep as it is, and code app will work. That blockchain application will. If you do you want to you want an explanation of this flow logic, or is it getting more?
So actually, we have running out of time. So shall we conclude it?
Okay, we'll do so. Yeah, no problem.
Yeah.
So
Okay.
I'll
Now.
conclude it.
Yeah. Okay, sir.
Yeah, give me a second. So
Yeah.
I'll
Okay.
conclude
Okay,
it.
sir.
So if you have run it in your laptops, if you face any error, please let me know. And like I said, these are the 3 points if you want to make it, and you should know some Java experience, or please try to learn some simple Java code. And simple is enough, because that is only enough, because everything else here is in package format. So here you can see in importer, everything is coming here in package. So you just need to give the corresponding details, and everything else will be taken care by Koda. So only those things you just, if you want to edit it, you need to know some basic knowledge. So that is only good. And yeah, that's it. And thank you guys.
Yeah. Thank you, sir. Now I invite Sanant S. Unitan to propose the vote of thanks.
Am I audible? Sir?
Yes, you are audible.
Okay. Good evening to the Honorable Resource Person, respected Dean, Nodal Officers, delegates from other institutions, faculty members, innovators, and my dear friends. No duty is more urgent than returning of thanks. Gratitude is not only the greatest virtues, but parent of all others. On behalf of Bhavan's Royal Institute of Management, I would like to extend our sincere thanks to Mr. Alok K. Venugopal for not only sparing his invaluable time for us, but also for enlightening us with his knowledge on the workshop, blockchain technology. Thank you, sir. I thank our respected Dean, Dr. Rajagopalan Nair, for his unending support and guidance. Thank you, sir. I mentioned my deep sense of appreciation to our nodal officers of IEDC for constantly advising and guiding us for today's event. Thank you. I take immense pleasure in extending my gratitude to the delegates from other institutions for sparing their time with us. Let me take this opportunity to extend my sincere thanks to IEDC Executive Committee members and innovators for their constant support and encouragement. And finally, I thank all the participants for contributing their time and making this event a grand success. Special congratulations and best wishes to the Bhavan's IEDC Ideathon teams, Team 5 Solace, Team 12 Wheel Crowd, and Team 4 Training Services, who have been nominated for regional level competitions of Innovators Premier League IPL. Finally, we have come to the end of events as part of Innovators Premier League and for the year 2021 organized by Bhavan's IEDC. Hope to see you all in the next session of IEDC. Thank you. Once again, thanking all the participants for joining, and special mention to Mr. Alok K. Venugopal for a delightful session. Now I request the host to end this session.